know the probability of A. So in other words, this one, A happen, how much is the based on B? Like that. Okay? Then the multiply by B, P of B, and divide by P of A. At this time, the meaning of this simple equation is, so this is called the likelihood. Before that, to understand, this is not statistics. Of course, some of the Bayesian theorem are explained based on the statistics. So it uses H or the X. Sometimes it's confused. So I'm going to use A and B simply. So this time, there are two events. You can consider A as a data, because we are dealing with the data in data mining class. B is class, because we are going to use a base for what? Classification event. This is a class. So for example, so we have a person coming, okay, A. This A person has several characteristics: age, and the salary, and education level, such a thing. Then B is, I'd like to know, classify this person based on what? For what? The buying computer or not buying computer. Or what? The buying the computer. The second class is buying car. Third class is buying the cell phone. Like the many things. The class can be many. Okay? It's not just yes or no. It can be yes or no. If you already know about the base based from your statistics course, it is called H, like that. Your hypothesis. Whether your hypothesis is true or false, that is your goal. For example, you heard about the spam mail or not. The goal is if the word, like the most popular word is the Viagra. The Viagra is if such a word is included in your mail, whether this is the spam or not. Yes or no. That's if the word is in, then it's a spam. This is my hypothesis. We try to prove whether that is true or false. It's a binary case. Most of the statistical approach use such a hypothesis, support the hypothesis or not. But in the classification data mining, class is not just two. We are going to use the binary classes, but it can be extended. That is this one. So can we measure the probability? Then later we will use this output as the classification. This is called the MAP, maximum posterior. Posterior. The posterior, which means among the different class B1, B2. Let's say B. It's complicated. B1, B2, B3. Highest one, buying cell phone. If this probability is the highest one, so this person, A person, goes to this one. We can use the base for classification. Okay? This is kind of a summary. We will see more details later. Then, how do we know? That is the problem, right? We already proved this one mathematically through the statistics. But you do better know the proof itself is just the couple of seconds. Problem is whether we understand the meaning of that. So this is called the likelihood, if you remember. The second week of the semester, I mentioned this one is a likelihood. Likelihood is what? Do anyone who remember what is a likelihood? When did you hear about the likelihood? Gradient descent. That is also gradient descent and the likelihood, and the other thing is for what? Optimization. So we'd like to optimize. In other words, we'd like to find the parameter that form a model. Okay, so this is kind of parameter, the probability of the parameter. So we already know. So this person, there are so many person data. Okay, so this is called the data. So P of A. So later we will see it because it's a little bit confusing later. Just understand P of A is the data. Then this, when a person is coming, we know which item this guy purchased before. Okay, how many? Many. Okay, we will deal with such a likelihood. In case of many cases, how can we calculate the P? That will be eventually naive Bayesian algorithm. But if binary case, buying or not, so we can have only one case buying. Positive case or negative case, only one case. Okay? Makes sense? If we have multiple classes, we need to consider all cases. Person buy this one, what is the probability? Person buy the car, what is the probability? Person buy the C, what is the probability? However, if we have binary means true or false. We have only one probability. This is we already know. Okay? It's this value parameter is already tuned. Okay? Based on my experience. So this kind of experience. Then, not always. How many chances? It can be huge important. So purchasing this item can be very important, or it's not very important. Even though this one is very high, a person is coming always buy car, but it's happen 0.00001, which is very rare. Okay, even though it's buying the car is only 10%, 0.1, but it happen a lot. So most of the buying case is firm. So chance. We can give the weight of buying this item. Okay. Then this one is for what? It's a data. Data means, so what is the probability of A? So when we talk about this time, so it's a total probability. It's not theorem, rule. Total probability, the rule. So for example, I'm going to explain one more time, but this may not important, but I think that you guys can understand. There are two box jar. So because we are going to use a jar. And each jar, so this is one jar, this is another jar. So there are two types of the board, two color. One is red, another one is blue. Okay? So let's say this one is 3 red ball and 2 blue ball. Okay? And this one has 5 red ball, the 1 red ball and 2 blue ball, like that. Okay, inside. So when you pick up so you do not know which one is which, but you pick up the ball is red. What is the chance of jar 1, box 1? Or what is the chance of box 2? At that time, the total probability of the box, selected box, is actually P the red. The total, the probability of red is actually 1 is from J1, right? It can be J1, and so you can select the probability of red from the J1. Also, you need to have the probability of selecting J1 and J2. They are actually half if the same box. But if size is different, it can be 1/3, 2/3, like that. So this one is multiplied by the J1, chance of J1, jar 1. Plus, you can get the red ball from the another box, red from J2. Then you can multiply the P of J, selection probability of J2. Then you can finally have the total probability of the selection of I. Because they are in the different. partition of the event. So different boxes. Not if they are in one box, it's simple. However, they are in different box, you need to add all of this. So when you calculate the P of A, so like this person, so P of A can buy, right? Or not buy in case of two case classes. In case of multiple classes, this person may buy this one, probability, plus buying this one, probability, this one, probability. So PA, probability of A, is actually sum of the A bar B and the P of B, and add up all class, all partition. Okay, this is the common mistake sometimes. So just the P of A what? But P of A will be based on total. It looks like that I can understand, or I may not understand. Let's take a look at the example. So through the example, we can clearly understand. Okay? The equation itself is very simple. That is one of the benefit of using this one. So what does that mean? The simple equation implementation is simple. So it's a several line code. That's it. And their accuracy is quite reasonable. So we will So this example shows the total probability. So this one is the case of the three different jars. Three jars and has a red, white, blue. For example, what is the probability of red but that is from the jar 1, something like that. At that time, we can use conditional probability, and the total probability of red is from jar 1 and jar 2, jar 3, you need to add them. Okay? That is the total probability. So you can go through this total probability. It's very detailed, explain. So I believe that you can understand this one. I'm not going through this because if I go through each and every detail, we cannot finish the class. So this is the total probability that you can understand. So if you do not understand, just remember this. Okay? P of A is not just the A, it is the A based on what? The B is true. A, the conditional probability, B is not true because A can be buying computer or not buying computer. A is sometimes buying computer, buying car, buying the cell phone. You need to all together. That is total probability. So this one explain such a total probability. So when this is the equation of total probability, when you consider the P of something D, so D is the red, white, the blue. So you need to consider all of this case to get the probability. Okay. Then finally, this is the base. What's the difference between this one and this one? First, B is not binary. It can be n number of cases. Okay, that's the keep in mind the front part. This one, our probability is we'd like to select the one class from among different class. So in my case, I usually remember this case from the buying computer. Okay, binary case, buying computer, not buying computer, or multiple case, buying computer, buying car, buying something other item. So based on what? It's an attribute, person. So attribute 1, attribute 2, attribute 3, like that. It's a data attribute. So describe the person. So this one then is the total probability. It's a summation of what? So if you have n number of items, the binary is just 2, yes or no. Okay? Buying computer, not buying computer. In case of multiple classes, all cases add up. And this is the what? It's a likelihood, it's a tune, this. For each one, in case of a binary, yes, by one, you can consider only one. But in case of n number of them, we need to address that. That is naive based. So set aside, we will talk about later. Then there, the probability. This is the base, the algorithm. Then we reach up to from the conditional probability, and the chain rule is nothing different. It's nothing special. It's just the A intersection B. Can be used for the proof of the base rule. Okay. Then in other words, when we calculate, our goal is to find the probability of buying computer, okay, or not buying computer, or something event B, okay, based on the attribute data. So if we feed on a lot of data, based on data, we'd like to decide something. Decision is event B, and this is the input data. At that time, observed data is this one. Observed data. That is observed data, and prior knowledge is this one. Especially P of V is a chance. How much important? How much important? This is our prior knowledge. It's a likelihood. That tune up our model. Okay, so then finally we can have the model. That model can be used for the classification. At that time, this kind of model is called generative. Generative means it actually, if there's one more, the input data, training data, it can actually modify the model. It directly feed on to generate the model and based on the training data. However, think about the decision tree. Decision tree, even though we have another training data, it doesn't change the model. Once we decide the attribute, most important, highest gain, the attribute, it will not change it. That's the use for the classification, which is called the discriminative model. So there are two types of such a model. One is generative, and another one is discriminative in data mining, when we build a model. This one is example of the generative model. Based on the data, this equation, if we have another data, it will be slightly changed. That's also benefit. If we have the new data coming, so this model can be changed. This approach can be used recommendation system, such as the Netflix, Amazon. They use such a the base for the recommendation system. Okay, and also it can be used for any types of data. That's another benefit. So like the time series data or decision tree, and even it can be used to build the decision tree and so on. So if you are familiar with the hypothesis in statistics, so you can understand my hypothesis is this. Yes or no support based on what? The data. So this is exactly same as this base, but I prefer this notation because we are dealing with the data and the multiple. Eventually, we need to handle the multiple classes. So, but still the doubt. I can understand, but whether this can be used for such a classification. Let's solve this problem. So. This is the most popular example when we learn the base, the theorem, and the derivation. So, in United States, I'm not sure, but in my hometown, so over 40 years old, one of the main social problem in United States, I believe, is insurance. It's very expensive, so sometimes not covered. It's very high deductible. It's like sometimes 5,000 up to the 5,000 you need to pay. So like not me, but you are healthy, so no chance to go to see your doctor except excuse absence. But So in my hometown, so it's kind of the government insurance. So government control the public insurance is mandatory. It's very cheap. So which means even though I'm not living in Korea, my hometown, so I still have the Korean passport. So if I go back to Korea and after a month, 30 days later, they send the insurance card. Then pay what? How much do you know? It's in my case, I do not have a job in Korea. I do not pay tax, but they charge only the in the US dollar is 120, like that. That cover even per month. As long as I stay in Korea. Because it's government control. So it's not the commercial. So it's a so that is the reason after retirement, a lot of immigrants go back to Korea. It's much better than healthcare and the Medicaid and so on, so they go back. And also, because of that, so think about the government, they use the tax. They need to save the money. Then how can you guys, if you are the governor, how can you save the money for insurance in that case? Early diagnosis. But in US it's different. It's a commercial, so if you, instead of early diagnosis, you can get the cancer. Then I can treat. Then he will pay more. But in government control such the insurance, they should reduce the money. How? Early diagnosis. So, for example, in Korea, it is required to get you go to your family doctor every year and pay a lot for the physical exam. Not only physical exam, it's a free. The physical exam plus check you can do the free CT and the MRI if in case of something wrong. And if you pay the $200 you can check up all the cancer, including in case of a female, the breast cancer is definitely free, and the popular cancer case. So it's really the good insurance system. So if you after the diagnosis, you see the doctor, then doctor said, so you have a positive for the cancer, the breast cancer. Then the doctor said the accuracy of the diagnosis, the method is 90%. And also he said, my doctor said, it is known that the 1% of the people have the breast cancer. Then, can you guess, so is it serious or not? Just roughly, what is your feeling? If you heard that this one, then what do you feel? It's a serious, right? So accuracy is 90% first. Then even though it's a 1% chance, what if so it's 90% the accuracy, but reality is much lower. It's not even half, not even 10%. So why? We will see. So using the Bayes theorem. So at this time there are two events. What we want to know is the A and the B. Right? B is what? Cancer or not? It's a cancer case. So we will check the one class, the problem. If true, it's a cancer. If not true, it's a not cancer. And or what is the probability of cancer? So what is the probability of cancer? Not just what? So probability of cancer is 1%. But in this situation, doctor said you are positive. So B is the cancer or not. A is positive. There are two events. So in case of positive, what is the probability of the B? Then how can you calculate? But our feeling is at least a 50% chance to get the cancer. But follow the Bayes algorithm. What is the probability of the B over A is A right? And the P of B, P of A. Okay, so what about the P of B? What is the chance? It's a 1%. So 0.01, right? The probability of cancer is this one. So in case of A, the probability of A, in case of B, B is a cancer. B is a cancer. That is a, what is the percentile? This one. So, what is the probability of the positive over P of B? That is P, A, and B times P of, sorry, I messed up. It's a B. So A and B is a point, it's a 9, it's a 0.001, and the A and B is a 0.9, 90%, okay? Because 90% accuracy of the diagnosis. Diagnosis means it's a positive. What is the positive? Where the cancer, right? So if among the real cancer, the positive case is the 90%, then multiply. The problem is the P of A. How can we calculate the P of A? At that time, we can calculate the total. The probability rule, that is the P of B times the P of B plus P A. Sometimes it's a positive. Positive case comes from what? The negative case. So not B. And times not B. Negative case is how much? It's a 0.99. So 99% is the non-cancer. So if you calculate this, as we can know that this one, we know that this, we know that this, we know that this. So this is I already did the calculation. So total probability is 90%. It's a 0.9, and the POB is the 0.01, and this is the complement, right? The 0.110%. And the not B is 99%. The not B is not breast cancer. It's a 0.99. So if you calculate this one, the denominator will be 0.108. Okay? Then the P of A is 90%, and this one is the 0.001. So if you calculate this, it will be like the 8.3, around 8%. So which means you don't have too much serious if you calculate this. Then why is lower than our intuition? Anyone? Percentage of population, very close. It's kind of illusion. Illusion of what? 90%. Okay, we just consider the 90%, but their accuracy comes from what? Not only positive, but negative case. Negative case is huge. Okay, you can get the 90% such a thing, negative case. That is this one. Because of this, so it can be much lower. So real breast cancer case is 1%, even though it's 90%. But my case is we don't know whether this is the real cancer or not. We need to consider both of them. But because of 90% of this, It's only for positive case. So then it's kind of an illusion. Okay, we need to consider the both of them. Okay. Question. There is another popular problem. So, 10 years later, I visit the same doctor again. Then the doctor says still positive. Okay. Then the diagnosis, accuracy of diagnosis is improved because it's 10 years later, 99%. And it is known that the 1% of people have the breast cancer. Then what is the chance to get the breast cancer? How much? Do I have to say yes? Maybe not? Maybe yes. Why don't you calculate? So it's right now, why don't you try? It's the same thing. Don't look at the next page. Then I'm not sure whether you or the note has this one. It's the same thing, but different thing is the 99%. Anyone? What is the percentile? It says 50%. Anyone else? It's the same thing, but only different thing is the P of the A. Okay? So you need to recalculate this, and then you will get how much? Half of 50%, which means should be serious. Why it happened? So let's first see whether that is true or not. So everything is the same except the A is different. So we have the 99%, which means the P of there is still the 1% chance. So then you can see this one, but this one will be 0.001, right? Because it's complementary. And also we can calculate the PA bar B, that is this one, then it will be 50%, which means it's a 99%, okay? Then it will be higher, it increased, okay? So it increased, so the other side is actually the increase this value and also the decrease the denominator P of A. So it's a rare chance, but it's happened. So it will be higher. Okay. So because of this one, it is the much higher than we expect what previous case. So this is the example of the very popular. If you take a look at any textbook or the example from the internet source, Wikipedia, they use the same. Sometimes they say breast cancer, sometimes other cancer, but this cancer example is very popular. The example, if you fully understand why, intuitively you can understand what is the base rule and how we can get such a result. Okay. Then, this is the one single or binary class problem. Binary class problem we can understand yes or no. Opposite of yes, okay? Which means it's still one class problem, hypothesis. But once we have the 3 or more classes, it's a multiple. So we cannot actually, we need to calculate this part. So before we start, I mentioned about the different modeling in the classification. We can actually group by 2, discriminative or the generative. I already mentioned generative model is the we try to feed on based on the data. So build a model. Incrementally it just is changing. Discriminative, actually decide. It will be used for the classifying. Which one is high, which one is low. Input will be used for the such a thing. That's the discriminative. The decision tree is the example of the such a discriminative. Generative is has the such a naive base. Okay. Then sometimes it is based on the model model based, but it can be used for the discriminative, which we don't discuss before. But any model based probability model based is called the probabilistic approach. So this naive base is a probabilistic generative model. At the time, such a probabilistic classification. Discriminative model is we are going to use this part, probability for the decision. Okay, the highest one will be used. So in case we have the input data A, this is A. This is a chance of B1, B2, B3, Bn. What will be selected? So car, cell phone, and computer. Computer, car, cell phone. And this one is the highest. Then we can decide. So this guy, X data, will buy cell phone because it's the highest the value. At that time, this is the discriminative model. So left-hand side will be used for classification, discriminative model. However, we cannot get directly such a data from where? From generative model, right-hand side. So this one. Right-hand side is a conditional probability. Is our experience. We know this guy bought this. This guy bought this. In case of car, computer, car, cell phone, 3 cases, there are 3 of them. The problem is how to combine them. Combine into one. How? Anyone? Combine means joint. It's a joint probability. However, if you make the joint probability, how do you? Each feature will be correlated, right? They are related. You cannot just multiply. In case totally different case, you can multiply. Like the twin, the rolling dice, you can multiply. The 1/6, 1/2, you can multiply 1/12 like that. However, if they are related a little bit, okay, we need to consider joint probability, joint event. At that time, you need to consider whether salary is related to the income. That is the same. Salary is related to the tax. Okay, tax is related to this one. You need to consider the related covariance. It will be very, very complicated. This guy has the number of attributes, x1 through the xn. This case, x1, x. You need to consider each and every cases so it will be much more complicated. Why don't we assume they are independent? Buying computer, buying car, buying cell phone, they never ever related, which means independent case. We can multiply. So we are going to assume to calculate the P of A by B, we are going to assume B1, B2, B3. In other words, buying car, buying cell phone, buying computer, they are not related. It's independent, which means we can multiply. P of B1, P of B3. Actually, A bar, A bar, A bar, B1, B2, B3, they are independent probability, which means we can multiply. Then we can actually have the multiply, then Px bar the C. Okay, that is naive. Naive means what? Naive. Simple. Professor Lee is naive. Simple to deal with. Right? If you bring a donut, so you will get A like that. So naive. So, but nobody bring the donut. Just ask. I need a higher grade. So if you make the distribution naive, how? Assume not related. The class, each class is actually that is true or not? It's not true practically, but we assume to simplify the problem. So cut this, they never interact. So assume that we can have this. This one, P of X bar C. You can calculate from the multiply C1, C2, C3. Okay? Then eventually you have this one. The other P of C, P of X, you know. P of C is your experience, P of X is the data. Then finally you can have the P of C, in this case P of B1 buying computer per input. Okay? At that time, we can use this discriminated to decision. How? Highest one will be selected. So that is called the maximum A posterior. Sometimes it's called the MAT rule. So you don't have to worry about the name. Just the highest probability will be selected for the decision, which means if B1 is the buying computer, B2 is buying the car, B3 is the buying the cell phone. If the A is coming, A is a person, attribute. So we know the a person. There's a person who bought the computer before. What is the probability? This person is a probability. This person, probability. Multiply. Then we will get the P of A bar B. And we know the P of B1, B2, B3. We know the P of A from the total, the statistics. Then finally we can have the B1, B2, B3 per A bar A. Then highest one. Let's say this is the 0.7. Then, and this one is 0.1. This one is 0.1. Then this one will be selected. Highest one. That is a math algorithm, but name is not important. We can select them. Okay. So this is a naive base. How to implement? You can code this part. Only this part. C, x1, C, x2, C, xn, C. Okay. X bar C. Then get the P of C per X, then we can easily calculate. What if item is 1,000? Yes, it works. Actually, the Amazon used the first time the recommendation system for the millions of them to recommend this one. So this is the naive based algorithm, and it will be used for the multi-classes, the classification. How? So there are two steps, as we have seen, not this one before. There are two steps in the classification: learning, training, then testing. How to learn? We can calculate the probability here, P of X per each case. Then test case is simple. Just put the value and highest one will be selected. It looks like easy to understand. So let's use the example. So this is another popular for the classification problem. We have used a similar one in the decision tree also. So we'd like to decide whether playing tennis or not. Based on what? If rain, we cannot play, right? Too hot, we cannot play. So by considering outlook, temperature, humidity, and wind. So in other words, A is weather. A's attribute, there are 4 attributes: outlook, the temperature, humidity, and wind. The 4 attributes. B is our interest, class. 2 classes, play tennis, not play tennis. Okay? In this case, we will consider 2. The play tennis or not play tennis. These are the data. Red one, for your easy understand, red one is the yes, the playing tennis. Black color, not playing tennis. So, to do that, in this example, we are going to build this one to calculate. To calculate what is the probability of play, what is the probability of not play. So, let's fill out the blank. So first, this is the left-hand column, right-hand column. First column is the playing, playing yes, not playing, playing, not playing, playing, not playing, playing, not playing. For each attribute, okay. The first attribute is for the outlook. This is outlook. Second is the temperature. Third one is humidity, and the first one is windy. Then there are 3 different cases of the outlook. Sunny is, so for example, I'm going to fill out the first box. I cannot write. Actually, the slide was used directly for the whiteboard when I have the projector. So play yes, not play. No. So we have the 3. The outlook, sunny, overcast, sunny, overcast, rain. Sunny, overcast, and rain. So what is the probability of the sunny? For the given yes. So which means among the red one, red is how many red? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, among the 9 yes case, how many times over sunny?
2.
1, 2. Means 2 over 9. So how many times of the overcast among the 9? 1, 2, 3, 4. 4 of them. So 4 over 9. And how many times of the rain?
3.
1, 2, 3. So it's total 6, 9. Yes, correct. And how many times of no? It's 1, 2, 3, 4, 5. Among 5, how many sunny?
3.
And how many overlook?
0.
I think that's 0, right?
Yeah.
And the 2
Rain.
rain. So this is the for what? First
Output.
case. Outlook. You can fill out that. Why don't you try for practice? You can try to fill out the other attribute, and finally calculate the P of the plane. Yes. How can we calculate? We assume all independent, which means multiply, multiply, and multiply. You should be careful to cough in Korea and China. Really. Even if you do not wear the face mask in public place, people will kill you. Nowadays. But I think that you should be ready. Such a virus will be eventually spread out to worldwide. I don't think that's really serious, but only because there's no vaccine or any treatment right now, it is scared. But it will be spread out. It will not hurt you, but you will not be killed, but maybe a little bit. So you can be ready for such a case, epidemic case. That's the same. I think 10 years before we had the flu, so Tamiflu was developed at the time for the new case of the flu. Actually, I have conference in Korea the beginning of the April, but I canceled because I'm holding the Korean passport, so I do not naturalize. But just in case if I'm quarantined, or if like the Chinese. The traveler, they cannot be here, or they stay 2 weeks in quarantine place. Okay, so this is this one is yes case only. So this is no case only. Then we are going to, based on that, calculate what? We are going to calculate this. So this is the learning pace, which means that this one, we calculate this. Sometimes this is your answer. So why don't you compare? And we have the P of the B. P of B is we can calculate the count 9 out of 14, 5 out of 14. So that is the P of B. So this is what? This is used for lookup table. So we can take this is kind of model we build. This is kind of the learning, the pace. Or this is kind of parameter tuning, optimized one. Whatever the name is, it's a model. Okay? So using this one. So test. Input. If we have an input like can you read? Outlook is sunny. Okay, today's outlook is sunny. Why don't you write down? The temperature is cool. Our temperature, today's temperature is cool. Humidity level is high humidity, and wind is strong. One more time, those who cannot read the data. So outlook, sunny. Right? Outlook is sunny. Temperature is cool. And the humidity level is high. And wind is strong. Using this input, this is A, input data. Okay? So we'd like to know that this data, A is this one, then what is the probability of B for given this? How to calculate? We can calculate this. Take a look at the table, and the P of B we know. Okay? So 9 out of the 14, and 5 out of the 14, and the P of A. So calculate. 2 of them, plane, not plane. Okay, you need to calculate the plane, not plane case. Then highest one will be selected. So these are the lookup table. I think let me show you that this one will be better. So outlook is sunny. Among the outlook, take a look at sunny is 2/9. Okay, select. First, you can do the yes case. And this one will be selected. Temperature is the cool. 4 is 3 out of 9. And the humidity level is high. You can select this one. And the wind is strong. So multiply. Okay. This one, multiply. Then multiply by what? P of B is 9 out of 14. Then you will get the value. Similarly, not plain case, no case. Anyone? Which one is higher? Plain or not plain? Not plain? You can use Excel if you don't want to calculate. Which one is higher? So plain case 0.0053. So you can multiply all of this. Yes. And not plain. No. Case and there 5 over the 14. And that is 0.02. So not plain is higher than others. Right? So not plain will be selected. So not plain is classified. That's the naive Bayesian. Okay? The difference between the base and naive Bayes, base we have only one, the likelihood. So no problem. However, in case multi-cases, multi-classes, we need to handle the joint probability. It's too complicated. So we assume the independent each other, which means we can just multiply. Then finally we can decide. So we can use such as the naive Bayes. What about the continuous? Continuous, we assume each conditional probability model as the normal distribution. Normal. What is similar as the normal distribution? Which other? Gaussian. So Gaussian is the distribution parameterized by what? Mean and variance. The normal distribution, the mean value will be shifted to where? 0. So normal, the distribution has a 0 mean value, but variance is still same. The benefit, only one parameter value. Normal. Right? Because the mean is 0. So we are interested in the only how much spread out the such a distribution. So we are going to use such a normal distribution. The reason is that the last time I mentioned about the Gaussian, because of central limit theorem, CLT. Any kind of distribution, if you repeat the random variable, it will converge to the normal, the Gaussian distribution. So that is the reason we can assume such a conditional probability is like the normal distribution. Then the other are exactly same. We can multiply. That is the reason. Later, when we are doing maximum likelihood, to calculate the maximum likelihood, we can actually multiply. So it's like this operation. The pi operation will be used. Any distribution and distribution will be multiply, and maximize this value is a maximum likelihood. If you log this one, because it's too hard, log is a log likelihood. So that is the continuous case. I'm going to skip the example of that. There are two main problems of using the naive Bayes. As you can imagine, is it true, the independence? It's not. So that is correct, but in the many examples shows that even though we assume that it's independent, it works for the classification. So even though it's not really the accurate, because we ignore such how much variety the class by class, but it works. The more important thing is the zero condition probability problem. So go back to here. So to calculate this one, we can B1 times B2, B3, like that. What if this one is 0, which means this guy never possessed this item? Or 0, because it's a multiplication. So it's a huge problem. So to address that, instead of 0, we can put the reasonably small value instead of 0 to avoid such a 0 point. There are several complicated rules, but I used only 0.00001. I think the 6th digit. So that is the kind of the reasonable for double. So you can the reasonably small value, okay, in order to avoid the zero condition probability. Okay, so this is a summary. First, the naive Bayes is simple. We spend just an hour to understand, and with several examples, it's practically easy to apply to many real life examples. Okay, so simply based on our experience, we try to predict. That's the idea. Even this, because this is a generative model, even though we have the bunch of different cases and huge amount of data, it works. And nowadays, however, when I was student, when I implemented this one, like the 1,000 classes and the 10,000 the data, memory is overflow. But nowadays, it's not a big problem. So the memory size and the computational power is working, and their output is reasonable, even comparative. It's comparable with the neural network and also the data mining technique. So we still use such a generative model. If you are interested more, I strongly suggest, why don't you, in your own hand, in your own code, implement this one. It's not very complicated. Even I have so far 2-3 master project student who used the naive Bayes for their project. One student did the recommendation system with the naive Bayes, then it works, and he published a paper, and right now walked nearby here. He emailed me the last week, be careful for coronavirus. Okay, so then go back to the main lecture note. I'm going to quickly finish, then we will have a break time, then do the exercise lab, finally. So this is a Bayes theorem. I like to use the P of B bar A. That's easy to understand as a data mining. But actually from the statistics, they use P of H hypothesis. It's nothing different, but it's up to you which one you use. So another example, this SPANMAIL is a very popular example also. And the naive Bayes assume, our assumption is attributes are independent. So this is another popular example, buying computer, not buying computer. So it's the same example that we used in the decision tree. So you can compare how much the accurate. Okay, so we have seen the mainly decision tree and naive Bayes. The decision tree is well known for the discriminative algorithm. On the other hand, the Bayes theorem is used for kind of the generative algorithm. There are several more. So next week we are going to see the neural network, perceptron neural network, eventually the deep learning algorithm as a part of the classification. Also we have the rule-based I'm not going to cover. If you can use if then else, that is a rule. To do that, you should have the experience. So sometimes the rule you find from the data mining technique, so like the decision tree. From the decision tree, if you find the rule that can be used, that can be implemented based on the rule-based the classification. Mostly if then else. So I'm going to skip this part. Then model evaluation. So last time we talked about how to evaluate the result. So these are the performance metrics. So we will see some of them. We have seen the last time. Accuracy, and this is the precision and recall F measure, and the ROC curve, and RMS is the mean squared error. So we have used in the what's that? The regression model, mean squared error. The root to mean squared error is because it's squared, so we can root. The RMSE and K divergence is the comparing two distribution. So KID is used for if your model is the statistical model, then you can use the KI divergence and so on. So most popular one is here. So we will take a look. Then again, the confusion metric. Definitely, this will be part of the exam. So it's very simple to make the question, like the confusion matrix and put the several 4 number. Then what is the precision? What is the recall? What is the F measure? And what is the accuracy like that? So this one is a true positive, definitely. So actually, buying computer, yes. Then I predict 69.54 out of 7,000. Okay, too much very accurate. But that's not the only accuracy. Even not buying computer, I predict this one. If you add up this among the total, that's the accuracy. However, if this will be biased, if data is biased, buying computer, if recall is among the total 7,000, I'm interested in this. I'm not interested in this one, the true negative. Only focus on true positive. Among the 7,000, I predict the 69.54. This is the recall. How many of, what is your recall from the true thing? Precision is, I predict 73.66 actually. This is wrong, false positive. So how much precise my prediction? So precision means how much precise the prediction. Recall is how much actually the recall get for this one. Our main target is this, right? So how many of them? However, if I predict so 7,000, 3,000, which means all of them are buying computer, recall is perfect. Do you understand? That is the reason when you are using recall, you need to also consider precision. How much precise? 10,000, 70%. So it's low. Okay? So that is the reason you need to consider when you are using the recall, also consider the precision. So this is a confusion metric. What if we have the 3, like the buying computer, buying car, buying cell phone, 3, 3, 3, 3, 3, 3. 3 by 3 confusion metric. 4 each you can have. So this is other confusion metric. We will see the more example during the exercise lab. Scikit-learn use the confusion matrix as an output report. We already saw this one last time. Okay. So precision and recall. F measure is the average of the precision and recall. So F measure is the average of this one. I think in your project, this will be most popular, the evaluation metric. If you to have a chance to take the signal processing, in the signal processing E department, use ROC curve. ROC curve is very similar as the precision and recall graph. So, but it's based on the sensitivity and specialty. Last one. So, how can we select the data set? So, in your data, some of the students during the page 1 mentioned about I'm going to use this as the training, this as the testing. So sometimes you can use the 70% for test the training and 30% the testing. So at the time, if you just select the amount of like the 70% or 30% or 50% for training, the other testing is called the hold out method. Okay, hold out method. Most popular, simple, but if you are not lucky, so all difficult data in the training, or the vice versa. All training data is simple, but the testing data is complicated. So it's the depends. So sometimes you can do the random sampling the several times, repeatedly, then average it. Have you ever seen the similar approach? Random forest. It's a kind of boosting. Random forest, did 100 times, average it. Similarly, you can do the similar thing. To address such a problem, unlucky, we have cross validation. You have seen the tenfold cross validation from your research. When you prepare the page 1 and also right now page 2, you heard about the cross-fold validation. Cross-fold validation is when you have the data set like this much. Most popular one is a tenfold. Tenfold means you are going to divide your data set as 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? First, this one is used for testing. The other 9-fold used for training. Run. Then next one will be used for test. The other 9, training. And so on. Then average. This one is called the K-fold, tenfold validation. So K is equal to 10 is most popular. So you may use the tenfold cross validation, or it's a number of iterations. Another approach is the bootstrap. So 0.632 bootstrap in case you have the not enough data set. So in case you do not have enough data set, you need to select and put it again, allow the replacement. Do it again and again. But if you keep doing such the activity like the put sample, run it and put the back, then shuffle and select again. So there are the rule like the 63.2% will be used statistically. So that's the reason it's 0.632. The problem is it's a bias. Okay, the other 36.8% may not be used statistically. So to address that, we can give the for the test set the 63% to the weight, and the training set 36.8 the weight. To avoid the bias. This is called the bootstrap. Nowadays, not much use. I never use such a bootstrap. Mostly K-fold validation, tenfold. You don't have to worry about too much such a statistical test. In case of a hypothesis validation, we can use the t-test. Confidence level is 5% or something like that. So 95%. We don't use the hypothesis, the evaluation, so we will skip this part. The final note is the classification problem is, in other words, is kind of building model. Okay? Sometimes it can be statistical model, sometimes it can be generative model, sometimes it can be discriminative model. No matter what method you use, our goal is to build a model, then use we try to use such a model for testing real data. Okay, then at that time, accuracy is the most important, definitely. Okay, But problem is how to evaluate your accuracy. That's also the important issue. I recommend to search the paper that already did the similar or the same the research. Then see how they evaluate their result. So that's one way. The most popular. Okay, that's not copying paste. Even recommend to use the same evaluation. Then the people can imagine. So your approach is better or the worse than the previous one. So you can use it exactly same. So such an evaluation metric. Speed. So if it takes a really long time, like the 10 years, to build a perfect model, nobody uses it. So speed. In other words, also scalability. When you have more and more data, and scalability is not only performance, accuracy. The more data you have, the better result, not always. So sometimes it can be overfitting. We talk about overfitting, underfitting, okay? Overfitting means it should be generalized but too much specialized, okay? So that is another issue. And also from the data mining point of view, whether we can understand the model. What is the meaning of the model? Then after we interpret, then we can reuse it for another problem, another model. One of the issues in the deep learning, even though deep learning, their output is really great, outperform, but the main issue is we don't know what's going on inside, hidden layer. It's very hard to interpret, just like our brain. Nobody knows how our brain process to recognize my friend, to understand, to make the knowledge. Same issue in the deep learning. So data mining, very interesting to understand the model. Then they would like to use such a model, interpreted model for another problem. But deep learning is slightly different. Okay, so that's the last part is ensemble. This is also, let me explain it very briefly. Ensemble means, what's the meaning of ensemble? Ensemble is combination. It's a combine, right? Ensemble. So, if your model is not good enough, another approach is, why not try another model? So we can use a multiple model. At that time, bagging is random forest. Do it again, then average it. That is a bagging ensemble. And the boosting is give the different weight. Think about a diagnosis as the cancer. I cannot believe that this doctor and going to paying the more money, then see the expertise, and then consider 70% and 30% like that. So depending on the classifier, so give the different weight. Then the booster, not just the average, and then I believe that this classifier, this model, then they give the 70%. This one, not sure, so 30%. So boosting, give the weighting. So then the average, based on that weight, that is a boosting average. Ensemble, use totally different, hybrid. So it's a decision tree plus naive base. Decision tree plus the neural network. So to decide the attribute, we can use instead of entropy, we can use the naive base. So such the combination of different heterogeneous model is called the ensemble approach. So ensemble, when we are saying ensemble, that means a heterogeneous classifier. Okay, I'm going to stop here today's lecture. Then after the 10 minute break, I'm going to restart the 7:50. Then we will do the exercise lab. I think the 30 minute may be enough to do our exercise lab. Please be ready for, I give you the copy, the SSH file, the WPA config file. If you hurt the boot file, we cannot restart.
No, but like I tried putting in my computer and it doesn't call it. I think I need to take a whole reformat.
So you reformat, then
I have a reformat.
You cannot reformat?
Yeah.
So can you see the F drive from your laptop?
No, yeah, I put it in my laptop and then here. Like maybe the drive.
Yeah, so why don't you come tomorrow? So I will give.
Okay.
Any other team who have the problem? Or anyone who cannot access? This time, I think that I'd better buy the better SD card. I think I purchased a cheaper one. So already the couple of teams that had a problem SD card. You may not have enough the ball pen nut and so on. Please find a way. You don't have to use all four the hole to fit secure. Only two of them is fine. Okay. So try to save the missing part. Okay. So let's start. So main purpose of the exercise lab is we cannot cover each and every algorithm before we start the project. So we cannot wait. So I already start the project A and also project B. But the problem is you don't know how to use the project. I'd like to use K-means algorithm, or I'd like to use something SVC or deep learning. So to address such a thing, the exercise lab introduced the machine learning or data mining, the library. So there are a bunch of others in the market and even the open source community. But I select the scikit-learn, which is one of the most popular one for the data mining technique. So even though we do not cover the several algorithm or all the algorithm, you guys can start and run the sample, then get the experience. How does it work? Okay, then apply to the real problem on your project. So that is the main purpose. So sometimes while you are doing the exercise lab, you can get the idea of what is the difference between the random forest or decision tree and so on. So that is the main reason. So also chapter 3 and will be the chapter 1 and 2. 1 is a setting up and the 2 is a very basic machine learning algorithm with the Python, mostly scikit-learn. So we will see the KNN, naive Bayes. We already did the naive Bayes logistic regression. Not support to vector machine. Maybe next week we will talk about the support to vector machine, decision tree, random forest, and the next week the neural network also. So you can test it in advanced several algorithms that we do not cover. Then think about your solution or method for the project A, the method. Then the deep learning. So for the deep learning, we can use we try to use a TensorFlow as a backend. Okay. So which means the tensor means it's a set of matrix style. So tensor. So they use the different the operations. So TensorFlow TensorFlow the library to help with the backend processing for deep learning. Then it will be used by the Keras because you can directly use the TensorFlow, but sometimes not easy. So we are going to use the Keras as the high-level programming. So Keras plus TensorFlow will be our solution. Is that the only solution for deep learning? No. There are many other solutions, but among them we select the most popular one. So first we try to run the very basic deep learning algorithm, then introduce the scikit-learn, the more detail. But I don't think we have enough time to cover each and every of the scikit-learn. I think that you can study by yourself the scikit-learn based on your requirement. Like we are going to use the ABC algorithm for the project A, so you can follow the step, then run how to use that. Then the chapter 5, the stop sign, the classification using convolutional neural network will be also used for the project B. So this part is important to be success in your project B. Okay? But in this, the exercise lab, we are going to use stop sign or not. But in your real model, you need to add multi-classes. Okay? So which means not only stop sign and the speed and the railroad and so on. So you need to extend the chapter 5 for your project. And chapter 6 and 7 is for RMM and LSTM. So first, we may not have enough time to cover each and every code line. I believe that if you have the very basic experience on Python, you guys can follow the instruction and do the exercise lab by yourself. But I think after today, we will cover the chapter 3 and 5 and 6 probably later, but not all of them. Okay? So, one more thing is I ordered the Curve extra, the louder. So I'd like to put the louder in this building. So if you try to use because night Wi-Fi I tested, but it always kick out. So connect again, so you cannot stay under the night Wi-Fi network. So alternative, the way to access your Raspberry Pi is you can use your hotspot here, but at that time please put your username and password of VNC. Then it can be connected to the VNC cloud. So from your laptop, you don't have to connect to your hotspot. Instead, the night Wi-Fi and access the VNC cloud. Then you are able to connect to the Raspberry Pi. You can save data plan, okay? But it doesn't use a huge data, okay? It's several megabytes, something like that, for the testing and developing. At your home, you can still use a home Wi-Fi and so on. So, but if you want to use the public Wi-Fi, I'm going to set up the router, then the TP-Link like that. But I'm ready. So if you're ready, so I will put so you can come to this first floor, then access it. So that's what I'm thinking. Okay. So to do your project, also this lab, I recommend Python 3.7 or higher. 3.6 is also fine. The reason is that the Python current version is 3.8, I think, if you install the latest one. But the other, like the Keras, the TensorFlow, they are a little bit behind. Because whenever the version is upgraded, they are the 6 months to 1 year slower. Okay? So because of that, when I test the 3.7, it works with the TensorFlow. But 3.6, if you have, you can still use. Okay? But not recommend the 3.8. Okay? So if you are using MacBook has as a default 2.7. So definitely you need to install the 3. At that time, you can go to the python.org and find the released version. Then download the specific version and install. I strongly suggest to use virtual environment. If you do not know what is the Python virtual environment, you can just follow the step. Basically, and if you have the operating system, you have the Python 2, Python 3, or even Python 3.6, Python 3.7, okay, like this. If you install the multiple times and different version. So sometimes your project A needs a 3.6, project B needs a different version, different one. So it's really confused, messed up. So virtual environment is for you can create one virtual desk. Okay, so working environment. So after you create the data mining one with Python 3.7. So if you log on the DM1, the virtual environment, it's always Python means Python 3.7. Then also you can install the required package under this environment. So it will not be confused with the other. So if you have another class like the Python class, you can create the PY, the virtual environment. That use a Python 3.8. Okay? Then the different package. So whenever you use the specific environment, you can log on and do it yourself. So this is a really convenient way to manage the different version. I strongly suggest to use this one, especially if you are using Mac. So because of Python 2, you definitely use this. And even though you are using the Windows, I suggest recommend to use the virtual environment. So how can? So you need to install the virtual environment package. Pip install the virtual environment. Whenever you see the $sign means it's a prompt. Okay, it's a prompt. I'm going to do the exercise lab based on the command line interface. So if you are not familiar with the command line interface, it is fine, but sometimes you need to run the virtual environment. If your IDE does not support the virtual environment, there's no way to use the virtual environment. But if the IDE, like a PyCharm and such a thing, allow the virtual environment, you can change. But my favorite IDE is the command line with the VI or the VIM. So you don't have to follow me, but I suggest the command line interface is a really powerful and a convenient way to do the programming, not graphical user interface, but other system programming, robotics, and even data analytics. Command line is really helpful. So not complicated, and also it looks like if you are using VI, like for example the VI, the basic, and the CNN, the PY, and if you set up the line of that and the search, the TensorFlow, like this, or the Keras, and you can go to the end of a line or beginning of a line and edit. It looks like a professional. You can show up. So during the interview, on-site interview, if we are using VI, it looks fancy, nice, if you can use the command line interface. So I'm old. I learned the computing and the computer organization operating system with the command line interface. So, but still being used, especially cloud computing environment. Even though they support the web interface, the command line, the interface is more powerful. Okay. So first, if you do not create a virtual environment, so please create your virtual environment. If you can check your Python version, to check the Python version, so you can type Python in the command line. So hyphen, then the version. You can see the 2.7. If you are using the MacBook, you need to type Python 3, then version. So mine is 3.6. At that time, when you create the virtual environment, you can specify 3.6. If you are using 3.7, 3.7. And if you are using the only 1.3 version, Python 3 is working. But if you have multiple one, so specify that. Then the last one is name. So VE is the name of my virtual environment. So if you want to use a different name, like the DM or practice or your last name, is totally fine. The VE is your name. Be careful. If you do not have a pip, what is a pip? Python installer, package installer, Python, whatever. So it's a tool to install Python package. Pip is the tool to manage and install the Python package conveniently. So if you do not have the pip, if you cannot find it, if you type the pip, so like for example, mine is pip, it's something out. But if you cannot find the pip, which means pip is not installed here, you need to download get pip.py file. So best way, search the Google and download pip for Windows like that. Then you can find the link. Install the pip on Windows. How to install pip on Windows? So there's a link. Okay, so you can download. This is the get pip.py file. Get pip.py file is the source code. So after you download, you can just run the Python. If you are using the 3, so Python 3, so on the MacBook. But if you are using Windows, you have only one, or the Python 3 version, then the get the pip, the py file, like that. Then run it. Then you have the pip. The first insert the pip if you do not have. If you have the pip and create the virtual environment, then to enter your virtual environment, you need to type VE bin activate. So if you successfully log on the virtual environment, you can see your name of virtual environment in parentheses inside your prompt. If you can see let me move a little bit. So if you see the VE or your name of virtual environment in front, you are ready. You are good. So please, first, check whether you have the pip or not. If you do not have the pip, download the get pip.py file, then run using your Python. If you want to install both Python 2, Python 3, 2 times. Okay? If you are using the Windows, so probably you have only the one, the Python 3. If we are using MacBook, Python 2 is default. So you need to always run Python 3, pip 3, like that, until you create the virtual environment. If you are not familiar with the Python, as I suggest, it's a good time to practice. And if you are taking the Python class, you will learn the mostly syntax, but Python has a lot of the tip and tool like that. Yes?
I'm not able to activate the virtual environment.
So what does it say?
It says that .v operation is not recognized. I need to know that. So.
The essay. I think that you are using the Windows, right?
Yeah.
It's not recognized as an internal external document.
Already
Create. And I never used the Windows. Yeah, I never used the Windows. So how can you start the virtual environment on Windows? Anyone? Here.
Scripts.
So
That's it.
Windows has a batch file, so you can run the batch file on Windows instead of this one. env script. There is the name of your virtual environment and script activate the .bat. Okay. So why don't you run the Windows? If you are using Windows, please check this one. If you don't want to complicate this, why don't you install the Git bash for Windows? Okay, Git bash is pretending the bash shell on Windows. It's not perfect, but you can still use the command line. So Git bash, Gitbash, is a bash shell for the Windows. It's not real shell, but you can pretend command line. For Windows user, if you really don't want to use a virtual environment, it's okay. Okay? But the Mac definitely need to create a virtual environment because it has a Python to always confuse. Okay, then continue. So if you do not install yet, you can install. The first run this command. These are the required the library that we are going to use throughout the semester. Okay, so for the Raspberry Pi, I already installed everything. So you don't have to install again. Instead, you can update later. But for your laptop, for your Windows, so you need to install these are the minimum requirements for the project as well as the exercise lab. So please run the line by line, or you can comma and install the multiple. It's up to you, but it may take a time depending on your computing power. Okay. Also, if you want to use the GPU, if your laptop has a GPU, instead of the TensorFlow, you can install TensorFlow-GPU. And also, you should use the library for the TensorFlow, but it's much faster. Okay. Why? Especially while you are doing the deep learning, convolutional neural network training, it's much faster based on the GPU. But if you don't want to use the GPU, just install the CPU version, the TensorFlow. The difference between the upgrade and without upgrade is upgrade always try to find the latest version. It tries to find the latest version, otherwise it's the same. While you are learning, I'm going to what each package. NumPy, most popular one. Those who are using the Python for the solution of data analytics, data mining, and machine learning. So NumPy should be in your laptop. Okay. So NumPy is it deals with the number, but it's a matrix. The operation is very useful. So later you will see the data set is a matrix type, vector, vector, vector. Eventually the matrix. So NumPy will be used for such the processing. PIL, the PIL, is the Python image library. So you need to learn the one by one this. You don't have to wait. Okay, why don't you run the one by one? The PIL is the very, very basic level image processing library. Okay, even though we are going to use the OpenCV. Later we have a chance to briefly introduce what is OpenCV. This is not computer vision class, but you definitely know. You should know the OpenCV library, okay? So many libraries of a single So what did you do just before?
केस होते नया आ जाता है ना। हाँ बस ठीक है वही यार प्रॉब्लम।
So, did you install the
नहीं मेरा नाम नहीं है। अच्छा यूजर्स के सामने मेरा तो 120 हो जाएगा तो यार।
First, virtual environment game. Did you install the
This is a link right now. It's not the major. I'm not sure whether that red wine that is a problem. Let me go through this one. First, search the Google whether there is a similar problem. Probably such a thing. Okay, so keep installing the library. So here is a very basic. Even though we are going to use OpenCV, we may not have enough time to explain about OpenCV. But definitely, you guys know how to use OpenCV. You cannot know everything. It's too big. Okay. So whenever you need, you can just search. So basic, the library used in the OpenCV, you should know, like how image read, I am read, or I am show, and how to work with the NumPy. Okay, so I will introduce very briefly later. But instead of using such a complicated not complicated but huge OpenCV, you can sometimes use such a very basic Python image library here. Scikit-learn is our data mining. The package, it's not just simple, it covers the most of the machine learning data mining technique that we discussed so far that we are going to discuss. So we are going to use the Scikit-learn for the exercise. Keras and TensorFlow will be used for the deep learning. So as a backend, as I said, we are going to use the TensorFlow. So if you are using the GPU, you can install the TensorFlow GPU, otherwise TensorFlow, which means it's a CPU version. And the Keras is the high-level programming. So then the TensorFlow, through the TensorFlow, we are going to use through the Keras, we are going to use the TensorFlow as a backend. So OpenCV, the pip install is simple, the very basic installation. I use the full installation for your Raspberry Pi. So for your project B, so you can use fully install the OpenCV library. So if you want to practice your OpenCV, I think the Raspberry Pi is the best option. You can do some basic operation for the pip install, but I recommend to use Raspberry Pi. Okay. It takes 2-3 hours for install, sometimes 12 hours from the source code to fully install the OpenCV library. Then IMUtil is an image processing utility. It's also the very basic. Sometimes OpenCV is not it's complicated. You can use the very basic image utility. Image processing utility. So please install this one. I asked you to install before this class begins. So some of the students already did, but if you are doing so, I want to keep moving. So for the practice, very basic practice. I mentioned not Irish data set, the UCI data set repository in your lab 1 and lab 2. The UCI archive is the most popular archive and repository for data mining and machine learning data set. If you want to download this, if you are looking for something specific data set, first go to the IRIS, not IRIS, the UCI data set. Also, you can search the cable. These two are most popular nowadays to find the data set. Okay. Among the bunch of different data mining data set, IRIS is the most popular. It's like the Hello World style data set. So if you go to the For example, this is a UCI, the archive. You can see the top right corner. Iris is the most popular one.
Yes.
So it's 3 million times it's used. The next one is 1.7. So Iris is the kind of the hello world size data set in data mining. So we are going to use the Iris data set. And also another data set is the 3C data set used in the previous research. So it's for the image processing later. For the convolutional neural networks, so convolutional neural network later we will discuss, but it was used for the image classification. It's an image. So for that the image data set, the 3C data set is, let me see, yes. It's like this one. So there's of course ocean. This of course, and another one is this is a forest, ocean forest, and the third one is a highway, like the highway. So we are going to classify the 3 classes for the image data set: ocean, forest, and the highway, like that in our practice. Okay, so if you don't want to download right now, why don't you go to the canvas and go to the file, the zip, the data set, as well as the source code. So you can download that file. Okay. First, this is the kind of practice when you download, when you collect the data set. So you need to understand what data set is. First, so the most important part is the attribute. So there are 4 attributes and 1 class here. The class is our goal. Okay, it's a labeled data. So the idea of the main purpose of the Iris data set is Iris is a flower, but Iris has 3 classes. One is Setosa, another one is versicolor, third one is virginica. So it's 3 different ones. I don't know which one is which, but they are labeled with the 4 attributes. So sepal is the under the flower. There are something, the flower supporting thing. Okay, that is the width and length. The petal is covering the flower. Okay, so by using the 4 attributes, therefore each one, so for each the iris, it has the setosa or the versicolor and the virginica with the attribute value. So 5 color and 4 attribute, 1 class. You need to check whether your data set has class or not. Sometimes class you can decide. I'd like to predict the temperature. Temperature will be your class. The other will be attribute, like that. So this is Iris data set. For example, this one. So you can see the 1, 2, 3, 4, the attribute. This is a class label, 1 over 3, the type of Iris, and you don't have to know right now, but in your data set, you should be expertise. Okay, you should know what each attribute is, and what's the meaning, and what is the variation, and so on. So that is sometimes it's called a feature, sometimes it's called the attribute, sometimes it's called the color. All of them are same meaning. And each line, each row is a data. Sometimes the data, sometimes items, sometimes instance, sometimes row. It doesn't matter. All of them are same meaning. Okay. In this case, we have the 150 the data. And 3-scene image data set, there are 3 classes. In this case, the data itself is the image. So we cannot line up the image line by line. Instead, one file is one data. One file is one instance. Label is a folder name. a lot of such an image data set use the folder name as a label. And under the folder, it has the data item or the files. Okay? That file mostly has the sequence number for identification purpose. So there are 3 folders, which means 3 labels, coastal forest or highway. Each folder has a number of the images, like this. The end of 5 more minutes. Okay, next time I will introduce the step. So let's start the program. So we have the classify underscore iris.py, the file. So if you open the file, you can use any ID, file editor for Python. Even you can use Notepad. If you are not familiar with the editor or ID, you can use Notepad. If you are familiar with the specific ID, in my case, I recommend the Python also. But if you are not familiar with such a new one, you can use the Visual Studio. You can use any ID support the Python nowadays. Okay, so these are the files. So I'm not going to explain the details of Python itself. So it has a bunch of the library imported. Okay, most of them are scikit-learn, the package. So we are going to implement the very basic classification algorithm model in one file. So KNN, we will learn the KNN. KNN is one of the discriminative algorithm, very popular. Later, the Gaussian, the naive Bayesian, and logistic regression we did. And this is software vector machine, we will discuss later. And decision tree and random forest, multi-layer perceptron, we will discuss next class. And then we discuss these classifiers are the implemented. So we need to specify the name of classifier. Okay. So 1, 2, 3, 4, 5, 6, 7 are included in this example. So we are going to use the iris data set. You don't have to download the iris data set. Instead, the scikit-learn provides to download automatically the scikit-learn data set. How? Here is they already, because the iris is kind of hello world style the data set, they provide the function load iris. You don't have to download, but you can do. If you download, you can import the data set. Otherwise, you can use load iris. Then when you load the iris, think about we need to do what? Training and test. For training, we need attribute and class. And for testing, attribute and the class name. So 4 different. Training, attribute, training, class, test, attribute, test, class. That is the train X, test X, train Y, test Y. X is attribute, Y is the class. So train Y means it's a training the class, like that. So you know the Python is very convenient to return such a function, the 4 of them at the same time. So this is the library, train, and test split. So we learn the tenfold validation or the hold-up. So this is a hold-up. What is the percentile? So you can see the test size is 25%, which means training is 75%. If you want a 6 to 4, so you can set up the test point 4 like that. Okay. Then you can see the data set, the data, and the data set target. Then the random state means if you do not specify this option in the scikit-learn, it will be random selection. So every time the accuracy will be different result. If you don't want the random, if you want same result every time, just put the same number. there is no specific meaning. Random 0, random 1, random 100, no specific meaning, but you know, there is no really random number in computer system. Do you agree? There's no really random number. Instead, there is a seed number. From the seed, you can generate the random number. So if you are using the same seed number, it's the same random process. It's not random, it's the same process. So you are going to specify the same seed number. That is so if you want to keep the same result, same test and data set, training data set, you can run you can give this one. Then build a model. Model fit is the training X, training Y. Means we are going to train. So train X is the attribute, then this is the class. So we are going to create the model based on training the data set. Okay, it's called a fit. The fit means creating model. Then after you create, we want test. Test is the prediction in this cycle. So predict test X. Okay. Then test Y will be used for what? Verification. Okay? Verification. So when you create the output result, classification result, test Y will be used. So that's overall thing. Always load data. Okay? And split data into test and training. Then feeding. Feeding means creating your model. Then testing. Testing is test the model. Then report. This is a general step in Scikit-learn. Not only Scikit-learn, most of the algorithm classification use the same step. So when you learn this program, so where am I? Desktop and CD Python and CD552. I download the file DM here, and then chapter 2. So Python and I need to give the model number.